Hey everybody, it's Chris Kresser. Welcome to another episode of Revolution Health Radio. This week I have an interview for you with Dr. Kara Fitzgerald. She received her Doctor of Naturopathic Medicine degree from the National College of Natural Medicine in Portland, Oregon. She completed the first Council on Naturopathic Medicine accredited postdoctorate position in nutritional biochemistry and laboratory science at Metametrics Clinical Laboratory, which is now Geneva Diagnostics, under the direction of Richard Lord. Her residency was completed at Progressive Medical Center, a large integrative medical practice in Atlanta, Georgia. Dr. Fitzgerald is the lead author and editor of Case Studies in Integrative and Functional Medicine and is a contributing author to Laboratory Evaluations for Integrative and Functional Medicine and the Institute for Functional Medicine's Textbook for Functional Medicine. Her latest ebook is The Methylation Diet and Lifestyle, which we're going to be talking about in this interview. She's published numerous articles in peer-reviewed journals. Dr. Fitzgerald is on the faculty at IFM, is an IFM certified practitioner, and lectures globally on functional medicine. She was formerly on the faculty at the University of Bridgeport in the School of Human Nutrition and is a clinical researcher for the Institute for Therapeutic Discovery. Dr. Fitzgerald maintains an active blog and podcast series on topics related to functional medicine on her website, www.drkara, that's K-A-R-A, Fitzgerald.com. And her clinical practice is in Sandy Hook, Connecticut. I reached out to Dr. Fitzgerald because I read her excellent ebook on methylation, and she and I share a concern about how methylation is being approached in clinical practice. Specifically, the genetic tests are being used to prescribe long-term high-dose methylation protocols, and some of the research suggesting that over-methylation may have some significant adverse effects and long-term risks, and the genetic tests are a really imperfect way of determining what kind of methylation support is needed. So there's a lot to talk about. Methylation's a complex topic. I've already covered it a few times on the show previously, but this is a new and I think pretty important perspective to bring to the table. And so let's dive in and talk to Dr. Fitzgerald. This episode of Revolution Health Radio is brought to you by 144.me. 144 is a diet and lifestyle reset program I created to help you dial in the 4 pillars of health: nutrition, physical activity, sleep, and stress management. Whether you want to lose weight, boost your energy, treat a chronic health problem, or just maintain your current good health and extend your lifespan, these are the 4 areas you need to focus on before anything else. In the 14-4 program, I walk you through every step of the process, from cleaning out your pantry and shopping for the right foods, to recipe and meal plans, to video demos of workouts that you can do at home without any special equipment, to guided meditation and stress management programs, to daily sleep tips, to personalized recommendations for what to do after you finish the reset. 14-4 is a great option whether you're just getting started with this stuff or you've been on the path for a while. In fact, I do a 14-4 myself 3 or 4 times a year to hit the reset button and give myself a boost. To learn more about how 14-4 can help you achieve your health goals, head over to 144.me. Okay, now back to the show. Kara, thanks so much for being here. It's a pleasure to speak with you.
Absolutely, and I am delighted to be with you today too on this important topic.
So let's, before we jump into that topic, I'd love to hear just a little bit more about your background and how you got interested in methylation in particular.
Yeah, absolutely. So by training, I'm a naturopathic physician. And then I had the privilege to do a postdoctorate in laboratory science at the lab Metametrics, which was in Atlanta, Georgia. Now it's a part of Genova, but it was an extremely progressive lab. We were looking at, the early omics, looking at organic acids, looking at amino acids, fatty acids, et cetera. We were looking at how genes are behaving to one extent or another. We were looking at toxins. Actually, we mapped out we offered a clinical test in the microbiome and so forth. So we did some really, really cool stuff. And then eventually we had access to single nucleotide polymorphisms. And, we would dance through biochemistry, sort of inferring, imbalances and what might be happening at the level of the gene. And so, I was also I was in clinical practice as well at the time and continued to be so, and lecture, and and working behind the scenes, writing and educating other professionals. And so I'm staying as current as possible in the literature. And the epigenetic world just exploded. And so being very interested in omics, I turned my attention there and began to look more and more closely at what was happening. And one of the best understood areas of the epigenetics is methylation, the methylation marks on DNA and, and other genetic material, and what they're doing and how, their role in disease and health. And, it changed my practice as that research unfolded, and it's continuing to, we're just in the middle of it now. There's, new studies being published just all of the time, and our understanding there is expanding exponentially. And so as I looked at epigenetics, it really compelled me to pause. So I came from this idea of, like this orthomolecular influence, the right amount of a nutrient and the right dosing, and you can affect biochemistry.
Mm-hmm.
You can influence the kinetics of a particular enzyme. I mean, that's where I came from, and I was really excited about that and liked to look at that in the lab, lots of various B vitamins and nutrients and so forth to really push reaction kinetics. But with the advent of epigenetics, it just caused me to pause. I mean, what are we doing to the epigenome? And this was particularly true with high-dose B vitamins, where, a lot of us kind of jumped on in the age of single nucleotide polymorphism. So when those became readily accessible, and when we started to look at them more and more in our patients, or, even our patients now are looking at them and treating them themselves based on what they think they need to do. So all of this, there was this wholesale movement towards really high-dose aggressive supplementation. So, layer in epigenetics and looking at hyper and hypomethylation and the association, the very strong association with, with really pretty much every disease out there. And I shifted internally. So. Right.
Well, we'll have plenty of time to talk about that, and I'm looking forward to it because I think it's an important topic, and a misunderstood topic, both professionally and amongst patients. But before we do that, I'd like to do just a little brief review of methylation and why it's important. We don't need to go into a lot of detail. I'm going to refer my listeners to previous podcasts I've done on this topic, and also blog posts for more detailed background. But methylation it's a concept that's, I think, a little tricky for people to understand. We often get a lot of questions about it as practitioners, and it can be difficult for people to get their head around. So given that we're going to be diving into the deep end of the pool and talking about some of the problems with methylation, approaches to methylation, we should probably at least start with some basics for people who aren't familiar with it.
Yeah, and absolutely just cut me off at any point in time, Chris, and have me restate, or
we can geek out, but we'll leave a lot of people behind. So I'll definitely do that.
Okay, good. Well, it's such a fundamental process. It's almost nuts. It's like mind-bogglingly fundamental. It's happening in every cell in the body, really pretty much all of the time. Either we're making the universal methyl donor, which is S-adenosylmethionine. We're making it, or we're using it in some capacity. We're doing it everywhere. We're using it to not only make DNA, but actually then go in and alter how DNA is expressed. We're certainly using it in the central nervous system, and immune cells, and neurotransmitter production, as well as metabolism. We use methylation to detoxify. We use it in the mitochondria and various phospholipids for cell membranes, and so on and so forth, and on and on. So it's incredibly fundamental. It's happening everywhere, all of the time. And it has its tentacles in really, what physiologic process doesn't it influence? And I think that reason it's difficult to kind of put your arms around it because of that, that level.
Yeah, it's so ubiquitous. It's almost easier to talk about what methylation doesn't affect, although that isn't very much. So
Right. Yeah, that is a good question. I would say that it's probably not much.
And the other issue with it, I think that's important to grasp how important methylation is to all the various body systems and processes, because that, of course, informs the discussion that we're going to have about potential adverse effects of long-term high-dose methylation supplement protocols that aren't, especially when they're not supervised. because there's so many different ways that can alter the function of the body.
Mm-hmm.
We're not just talking about one limited area. We're talking about everything from detoxification to neurotransmitter production and metabolism, to turning on and turning off genes that affect pretty much everything, to, the hormone clearance. There's so many areas that can be affected.
Mm-hmm.
So
that's right.
We need to be careful.
That's exactly right. And because it's so far-reaching, as we began to put this program, dive into the research and then really just put this program into place in our clinic, when you look in the data around how you can safely impact methylation, so you're not always, and we're going to go in this in more detail, but so you don't always have to lean on the obvious methyl donors, B12, folate, et cetera. Inflammation can negatively impact methylation,
Sure.
Whether you're exercising or not, what's going on in your gut, your microbiome, your mitochondria, what medications you're using, the foods you're eating, et cetera, et cetera. So all of these things that we don't think about as potently influencing methylation do influence methylation. And it's here that I think we've got our strongest leverage points. Let's go way upstream and look at diet and lifestyle.
I think that's the good news about this show. And if you're pressed for time and you just want the takeaway, I'll give it to you right now, which is that it comes back to the same thing, diet and lifestyle, and particularly this ancestral perspective of where we realign our diet and lifestyle and behavior with our genetics and our biology. And, continually when the reason that is such a powerful lens for me is that when things start to get really complex and they seem overwhelming, you pull back and you look through that lens, and it often brings us back to the same interventions that we talk about all the time, getting adequate sleep, managing your stress, eating the right foods, anti-inflammatory, nutrient-dense diet, making sure that you are getting the right kind of physical activity, not too much, not too little. So that's the really good news. This can seem really complex and overwhelming, and to some extent, when you dive into the details, it is. But from a practical perspective, what we all need to be doing about it is still pretty, maybe not easy, but simple.
Yeah, well, I know it's equally exciting for me too, Chris. Like the more omics we have available, we've mapped the genome, we're looking at the exposome and the epigenome and the transcriptome and the microbiome, et cetera, et cetera. The more omics data that we've got, like we're swimming in, the more upstream we go, and the more we remember, like take a breath, and get your sleep. So,
exactly.
Yeah.
So let's set this up, because this is a trend that's, been bothering me for some time. And it's one of the reasons I reached out to you to do this interview. And I found your book and read it and enjoyed it, because I thought, okay, this is, someone else who feels the same way about this and has done the research and understands the risk here, because this is the phenomena that, we've seen. I think it's starting to back off a little bit, but for a while, everyone was talking about genetic testing for methylation using 23andMe. And I had, patients coming in to me with shopping bags full of supplements that were recommended to them, sometimes by a practitioner, but other times by an algorithm.
Yes, I know.
That's used, from a website that interprets these genetic results looking at single nucleotide polymorphisms, or SNPs, in genes related to methylation, which we'll talk about in a second. And then the website actually makes supplement recommendations based only on these polymorphisms. Not looking at any functional markers of methylation or the patient's diet or lifestyle or anything else, just making supplement recommendations exclusively on the basis of these polymorphisms, and not telling the patient to ever stop taking those supplements. So I had people coming in who've been on high-dose methyl donors and a whole bunch of other supplements, some of which really kind of conflict with each other for years at a time. So let's talk about what's wrong with that approach.
I know. Gosh, I know. We've all seen that. I think anybody who's working in this sort of functional medicine space is seeing that, and such anxiety, I think, too, with these single nucleotide polymorphisms. I had a patient exasperated. I think I mentioned her in the preface of my book, saying, I can't detox. And,
Let me just add one more thing. I know you've seen this too. some patient comes in and says, I'm heterozygous for MTHFR A1298C, so my methylation is all screwed up.
Yeah, that's right. That's right. Absolutely.
And like you, along with 30% of the rest of the population.
Yeah, at
At
least. That's right.
Let's kind of pick this apart, starting with, let's talk a little bit about the genetic testing and what it can and can't tell us and how it should be used. What's the appropriate use for that testing? And then we'll move on to why jumping in and staying with a high dose methylation supplement protocol may not be the best option, even if we do determine that there's a problem with methylation.
So, I think there's a place for SNP testing. I think it's pretty cool. But, they are, by definition, extremely, extremely common. I mean, we all have, 4 million of them? And I think it's kind of interesting. I think when we use it as a sort of suggestions, and when we go way upstream with how we address it, if we address mostly through food, et cetera, I think it can be a useful tool. Or if we allow it to guide us in healthier lifestyle changes, I think it can be useful. But the fact of the matter is they're incredibly ubiquitous. Any single SNP isn't associated with extremely strong data around it being, a major deal breaker. They're just risk factors. They don't, they're not shoo-ins for disease. There's suggestive risk factors. I know like MTHFR or, the ApoEs have a little bit of stronger data around them and are worth, paying attention to or working with a clinician to kind of pick through and see whether they're making an impact and, how you might support it. But I think for the most part in this, where we are now in the current state of investigation, we don't have a lot of answers. I think, Chris, honestly, what's going to emerge as systems medicine becomes more available to clinicians, these big, massive databases are more available to us, we will start to see SNP patterns emerge. A collection of certain SNPs being associated with increased risk. There's actually a pretty cool 2011 paper out looking specifically at breast cancer risk and manganese superoxide dismutase, cytochrome 1b1, glutathione transferase, and to a lesser extent, COMT. So in different patterns of these collections of single nucleotide polymorphisms, there was an associated increase, and in some cases pretty significant. And I think we can use that to guide us in a much more effective way than just, clinging to, handfuls of SNPs and drawing conclusions about our health from that.
Right. And then we can combine functional markers where we can look at actual predicted downstream effects metabolically of those SNPs, and we can see if they're actually occurring, which is what we do in our practice. And, if someone has SNPs that might predispose them to impaired methylation, but they have no functional markers of impaired methylation, then we're going to approach that person differently than someone who has SNPs that, suggest a risk, but do have impaired, functional markers that support that. And even someone who doesn't necessarily have genetic markers of risk, but does have many functional markers that show that methylation is not happening properly. It can be any of those permutations.
That's exactly right. So you always want, to the best of our ability as clinicians, we want to dance around the various biomarkers that might give us some insight into what's happening at the genetic level. Absolutely.
Yeah. So let's say we do that, and you or I find a patient, we have a patient who's got some, maybe they're homozygous for MTHFR C677T, which, as you said, is one of the SNPs that has the, more research behind it than others, perhaps, especially for people who have two copies, which is more rare than people who just have one copy, which is very prevalent. And then let's say we do some, we look at their homocysteine and it's elevated, and we look at their oxidized glutathione and it's high, and, we see some other markers and we say, okay, this person has a methylation problem. So, so far the kind of the approach that has been advocated most commonly and that I've used myself at times, is to go in with, high dose B12, methylfolate, folinic acid, trimethylglycine, and all these other compounds, typically B vitamins, but also some others that support, that are part of the methylation cycle. So in your research, What did you discover that gave you pause with doing that kind of approach for a long period of time?
Well, probably so as I said in the beginning, the research on the epigenome is just galloping ahead. There's a lot of animal research. There more and more human studies are coming out. There are cell studies and so forth. But we know without question that hypermethylation of the promoter regions of DNA are associated with shutting down gene promotion or expression. So when the promoter region is hypermethylated, then that particular gene can't express. And that's been shown to occur in many different disease states, but most powerfully and consistently is cancer. Really, virtually every type of cancer is associated with this promoter region hypermethylation. And there are plenty of data at this point. I mean, the human stuff is still emerging, but it's there to show that folic acid, I mean, we've got a lot, we've been fortifying grains for a long time now, so we have more folic acid data than others, but absolutely increases this potential for hypermethylation. So higher dose folic acid exposure leads to this hypermethylation state. And it shuts down. So it's literally shutting down this gene expression, and these genes are tumor suppressor genes for one. So our ability to fight cancer is inhibited, and we see this like the BRCA, the famous BRCA 1 and 2 genes can be inhibited by hypermethylation. So you don't have to have the mutation. You can it can be shut down and participate in cancer, oncogenesis that way.
With those studies, when you were looking at folic acid, was there any differentiation between the effects of unmetabolized folic acid because of our inability to process that effectively versus high dose methylfolate?
No, they're not out there. But what's clear in the research is that SAMe, so production of SAMe is, that's the cofactor for DNA and methyltransferase enzymes. And I mean, so anything that's pushing methylation in any capacity. So if you're using those natural or bioidentical methyl donors, you're going to be increasing SAMe production. You're going to be, pushing methylation reactions forward. We know that hyperhomocystinemia, when you normalize hyperhomocystinemia, that hypomethylation of the epigenome also improves. So I actually want to step back for a second. And again, just step in if I'm getting too complex. So there's promoter region hypermethylation that's associated with many disease processes. Most well studied is cancer. So these promoter regions are shut down. Tumor suppressor genes are shut down. But in the rest of the genome, there can be methylation or hypomethylation, insufficient methylation. And interestingly enough, that insufficient methylation can be associated with oncogenesis as well. So these oncogenes can be allowed to be turned on because they're not methylated. So it's an imbalanced methylation picture.
Right.
So we want to support, methylation, hypomethylation is associated with its own
problems,
without question. And so we want to support healthy methylation, but we also don't want to push it aggressively because there is suggestion that it will lead to hypermethylation.
Mm-hmm. Yeah, and I think we see this. I mean, this shouldn't be surprising because we see this in other areas as well, where we know, even looking at things more simply, that most nutrients have a U-shaped curve in terms of sufficiency. If you have, iron is a good example. If you have too little iron, you get anemia. If you have too much iron, you get hemochromatosis, or you get iron overload and the effects of hemochromatosis. And that's actually the rule for most nutrients. There are exceptions like B12 and vitamin C, which seem to be tolerated at very high doses without obvious ill effects, except for potentially some of the ones we're discussing now with B12 and methylation. But they're not toxic in the way that other nutrients are. But typically, when you're talking about nutrients that we need, we're talking about a balance. We're not talking about more is always better. And so it shouldn't be that surprising for us to see this in the world of methylation.
Well, and it was just going back to your other point. Have we seen natural methyl donors influence DNA methylation? And so there was a study that showed epigenetic methylation improved as homocysteine was treated and dropped. And there are human studies absolutely looking at that and noting that shift.
Right. So I think it's a really good paradigm shift to start moving away from this mentality of like this kind of oversimplified idea of you have a SNP, that means your methylation is not working. Then you add these things, these methyl donors, and it fixes the problem. And we need to move more towards this paradigm that you're suggesting of balancing methylation. So, in some areas, methylation may need to increase, and in other areas, it may need to decrease. And we don't have the knowledge yet to be able to approach it with that precision, but the body does. So we need to support the body in doing what it needs to do. So if we think of strategies for doing that, in your book, you talk about like two basic categories, things that can improve methylation, but also removing factors that inhibit methylation. And I think that second thing in particular, that second strategy has been the one that's been neglected the most. So let's talk about, what are some of the things that inhibit proper methylation that we could then intervene where we can intervene so that just the body starts doing what it knows how to do naturally.
Yeah, that's right. A great question. I know this is where the rubber meets the road. So we know that certainly if we're not eating a good, rich, whole foods diet, that we're not going to be ingesting adequate methyl nutrients, methyl donors, adequate protein. We want to make sure we have choline. Choline is a major player. All the full complement of vitamins and minerals. So we need so diet.
Which you outline. I just want to jump in. You outline very clearly in your book. This is really for people who want this level of detail. It's awesome. She's got tables with all of the nutrients that are supportive of methylation, and then exactly what foods you can find them in, which I really appreciated, because that's time consuming to do that kind of research, and you've done it for everybody. You make it easy. You could just look at it and say, okay, I'm not getting these nutrients because I'm not eating this category of foods. And when you look at that list, you see, you need a diverse, nutrient dense diet, which is of course what we're always recommending anyways.
Yes. Well, but there are some so-called methylation superfoods, and we've got our whole list where you can really lean on those, especially if there's reason to. So if you see these biomarkers, or if you're concerned about a certain SNP pattern, then you can lean on some of them, like beets and spinach and mushrooms and
organ meats are always on high on the list. Yeah, shellfish.
Yep, that's right. And it's good. I have to give a shout out to my nutritionist, my co-author, Romilly Hodges, because she just worked endlessly at putting together those recipes and getting all of that data that you've just mentioned. It was it's an amazing labor of love, and it's really done well in our clinic. Our patients have responded to it fabulously.
Great. Okay, so nutrient dense diet, we've got that one.
Yep. And we're thinking about, our microbiome. So all gut function in general, as you've talked about to your folks ad nauseum. But, our microbiome is going to make or break methylation locally. It's going to influence it globally. And it's also going to help make, methyl donors like folate. And some of the microbiome major players can actually consume folates a lot. So do we have a nice balance? And it looks like most of the bifidos are more likely to be folate producers. And there's pretty interesting research out looking at lowering homocysteine just using Bifido adolescentis, I think it was.
Interesting. Yeah, that's interesting. Mm-hmm.
I know. It's so cool. Just Bifido. And this was actually in dialysis patients. So it was a select group of patients, but there is plenty of research out there showing that Bifido can make a lot of folate, whereas lactobacillus tends to be consumers. So we can take care of our microbiome, not just to allow those nutrients to be produced, but just to nourish general epigenetic methylation as well.
Mm-hmm. Mm-hmm. And you mentioned before, there's chronic stress inhibits methylation, environmental toxins.
Well, and chronic stress actually as a poor diet does, toxins, et cetera, lead to what we call aberrant methylation, or that, that hypermethylation occurring where we don't want it, and that hypomethylation occurring where we don't want it. So that aberrant, imbalanced methylation is going to be pushed hard with a high stress lifestyle, with insufficient sleep, with toxin exposures, really all toxins. You can see the metallotoxins, but lots of research on the organotoxins, the POPs and so forth. And, sugar, like just a poor quality diet can alter methylation in a powerful and lasting way, allowing for upregulation of inflammatory proteins. And then those inflammatory proteins will in turn alter or cause imbalanced methylation. Yeah, and it goes, it's a web. It's very interconnected.
Absolutely. And I think the more I've thought about methylation, I start seeing it more in the context as a mediator or a mechanism that sits between environmental inputs and then the expression of pathology and disease. And that's how I understand the microbiome. And Justin Sonnenberg has talked about the microbiome that way as, rather than seeing it as kind of a separate disease influence, the best way to look at it is as a mediator of all of the various environmental inputs and how they could lead to disease in the body. So to use an example, poor diet leads to disruption of the microbiome, which then leads to inflammation, which is the root of all chronic disease. Physical inactivity causes adverse changes to the microbiome, which then leads to blah, 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 blah. Stress causes changes to the microbiome, which leads to blah, blah, blah. And then we have the same thing with methylation is sitting there in the middle as well. Like all the environmental inputs that we're talking about, the way that they actually cause disease is via methylation and the microbiome and some of these other primary mediators. And not only that, as you were just pointing out, these mediators affect each other. So that stress affects the microbiome adversely, which then probably adversely affects methylation, which then adversely affects the microbiome. And it's this vicious cycle or web. And it's, so again, it's complex, but the simplicity is beautiful because it just comes back to doing the things that we know we need to be doing.
That's right. And there's a lot that that we're already doing right, which is exciting. However, I do think this book is cool because we spent a lot of time doing a drill down into, how we can directly and aggressively address it. And we've seen that bear out with the biomarkers in our patients. One of the coolest areas of research for us that's been it's just endlessly exciting is looking at these methylation adaptogens. Can I talk about those now?
Yeah, please.
Okay. So as we're talking about this aberrant methylation, this imbalanced hypo and hyper, and what do we do about it? We know we have to have these methyl donors. We have to support global healthy methylation. So we do all of that in all of the ways we've already talked about. But how do we support, how do we inhibit this hypermethylation process? How do we allow for this balance? So this is where this whole class of compounds that we're calling methylation adaptogens, actually that term was coined by my friend Dr. Michael Stone out in Ashland, Oregon. These are compounds that seem to have a balancing effect. And they are, again, players that we're consuming all of the time if we're eating a good whole foods diet. They're all of our plant polyphenols. One of the major ones that has clear adaptogenic properties is curcumin. So it can actually promote healthy epigenetic methylation as well as inhibit the process of hypermethylation at those regions at those tumor suppressor gene sites: curcumin, sulforaphane, luteolin, lutein, lycopene is a big one, rosmarinic acid. I mean, all of our go-to polyphenol compounds seem to have this beautiful capacity to balance out methylation. And I think as research continues to come down the pike, we're going to see that these compounds that have a, long traditional use history, act at the epigenome as one of their primary sites of influence. I mean, we know curcumin, you can look in data and find a zillion different mechanisms for it. I think a big one is the fact that it can augment epigenetic methylation expression.
I love this concept of adaptogens for methylation because it's so much more in alignment with our understanding, what we've been talking about through the whole show, this concept of balance rather than, hitting the gas really, full pedal to the metal sort of thing or slamming on the brakes. which seems kind of crude, as a means of intervening in a system that's this complex. And it's really more, and I think not to get too far off on this tangent, but this to me is emblematic of the kind of paradigm of allopathic medicine, which is based in a kind of war, often uses metaphors of war and attack, and this kind of idea that everything is separate and the whole is just the sum of the parts, and we can, we have sort of ultimate power and control and understanding, which I think is a complete fallacy. And the more we, like anything else that's worth doing and learning, the more we know, the more we realize we don't know. And for me, as a practitioner, that makes me want to embrace a paradigm that is more about kind of like tending the garden and facilitating and supporting and recognizing the wisdom and complexity of the ecosystem of the body, and realizing that there's still a lot we don't know. And so the best thing that we can do is to support the body in doing what only it really knows how to do at this point. And I've used this analogy with discussion about Th1 and Th2 autoimmunity, and like this idea that we know how, we can just go in and support Th1 or Th2 in all these various disease states, which was pretty popular early on, which we now know is really, it's not that simple. And the best thing to do is to support T regulatory cell function so that the body can take care of itself and decide what it needs to suppress and promote. And I think that's relevant here with methylation.
Absolutely. Yeah, just put the nutrients in and allow the body to make the decision points. It's just it's very cool. D3, retinoic acid, even DHA, all of these guys seem to have this epigenetic balancing capacity.
So let me ask you this. This is an interesting question that we're exploring. I'm curious to hear how you guys are approaching it. There's, most patients I've seen, the diet and lifestyle interventions, addressing all of using a functional medicine approach, basically. You removing factors that inhibit methylation. Some of that is diet and lifestyle change, but some of it may also be if there's a cause of inflammation, like a gut pathogen, you have to address that, right? So it's the same kind of functional medicine approach. Many people will experience a reversal of their, an improvement of their functional methylation markers like homocysteine. What about the patients who do those steps and for whom we address, the functional, we go through the functional approach and address their various issues as well as we can, but their homocysteine is still, 17, and they still have other markers of impaired methylation or imbalanced methylation? Is that where you're using the adaptogens? Have there been patients for whom you have needed to use methyl donors for a shorter period of time? What's your current approach there?
So I do have some patients, I think we all do, who absolutely don't tolerate methyl donors of any kind. Either they heighten anxiety, super sensitive. And for those folks, we've, if they're willing to jump in and really adapt to this, we can absolutely improve their biomarkers and lower homocysteine. They have to really hang in there with it, in their methylation index. You can look at SAM and SA, and, you can see that improve with this program. No question about it. I might give them a little bit of choline as well, if they can handle choline, or just have them, go heavier on eggs, or a little creatine. We spend a lot of S-adenosylmethionine making creatine, a ton of it, to just maintain muscle mass and energy. And so if you could do a little bit of creatine, that can be well tolerated, and that helps as well in hypersensitive people. But I don't have a problem at this point using methyl donors and sometimes high-dose methyl donors, but I have an endpoint now. I absolutely have a clear endpoint. And we introduce the methylation diet and lifestyle principles to our patients immediately, and then transition them on to that more and more. So we'll move through the heavy therapeutic phase, which can include methyl donors, but they're transitioning into the methylation diet and lifestyle principles. And we're stopping the methyl donors.
Yeah.
I do, if somebody's in an active disease process or they have been diagnosed with cancer, I might be a little bit more careful and really have, a very clear reason for using high dose B vitamins and have a clear stopping point. I mean, I think with, in oncology, we need to be way more conservative here than we've been.
Yeah, I agree. And that's pretty much how we're doing it. So it's interesting to hear you say that. And it's kind of how we do it with everything. I mean, with the gut, we start off by, we do testing, we find stuff that needs to be fixed, and we fix it often with supplements or sometimes medications. But then from there, we always, want to move the patient to a prevention program where they're eating plenty of fermentable fiber and fermented food and, a gut healthy diet so they don't end up in that place again. And it sounds like, with methylation, that's kind of the same thing. In some cases, patients are going to need heavier handed might not be the best word, but like a more intensive intervention up front to get them back into that range of tolerance. And then once they're in that, it's like the engineering concept. Once they're in that tolerance range, it's easier to maintain them in that range than it is to get them back there in the first place.
Yep. That's absolutely right. Although, I've been really kind of pleasantly surprised seeing just the MDL program work on its own and seeing those biomarkers that you would normally interpret as absolutely requiring high dose methyl donors, not needing to do that. It's pretty satisfying to see that happen. It's really pretty cool.
Yes. Yeah. Yeah, I've seen that as well. Well, I wanted to, just put in another plug for your book. It's an excellent resource for people. There's so much information about all of the various interventions from a diet and lifestyle perspective that can support methylation balance, and including all of the tables with the various nutrients in foods, and a much deeper discussion of everything we've covered, including the research on the danger of overmethylation or imbalanced methylation. And I really recommend it. It's a great resource to have on hand, whether you're a patient just trying to work this stuff out yourself and make sure you're protecting yourself, or whether you're a clinician and you're interested in a more balanced approach to methylation. I really recommend this. And Kara was generous enough to provide a discount code for our listeners, which is Kresser 15. Where can they find your book? Where's the best place for them to get it, Kara?
Just it's on our website. It's a downloadable ebook. So just go to drkarafitzgerald.com. So DrKaraFitzgerald.com. And you'll see a link right on the homepage to the methylation ebook.
Great. And so what's next for you? What are you working on? What's on the horizon?
Well, I'm about to jet off to Austin and I'm on faculty for the Institute for Functional Medicine. So I'll be doing the immune module, which is a lot of fun. And we're actually, Chris, what we're working on doing that's super cool. I mean, I'm excited. I love doing my IFM stuff, but we want to research this. I mean, so we're working on a proposal. We just really want to put it to the test, and and have as big of a cohort as we possibly can manage. So that, to me, and then publish on it, write it up, demonstrate what we're seeing, use some biomarkers. I'd love to actually have epigenetic data. It's not available clinically yet, so it's in the it's only accessible in the research setting. But I want to do that and just show that. Just show that this upstream, hopefully, show that this upstream approach really can make a significant difference. So that's one of the most exciting things on my horizon.
Yeah, cool. That is really exciting. I can't wait to see that data.
Well, I'll keep you posted for sure.
Good. Well, thank you so much for joining us. I really enjoyed this discussion. I think it's going to help a lot of people, both patients and clinicians alike.
Thanks for having me, Chris.
All right. Take care.
Bye-bye.
That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at chriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/Chris Kresser or facebook.com/Chris Kresser LAC. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.